Hello everyone, welcome to this session on centroid. Now today we'll have the derivation on a quarter circle. Previous three classes we had the derivation on rectangular section, triangular section and semicircular section, and in this particular session we'll have the derivation of a quarter circle. To have a small recap, what were the formulas related to rectangle section, triangle section and semicircle section is. We had considered a rectangle of dimension b and d being placed in x and y direction, and the center of this particular rectangular section along the x direction was b by 2 and along the y direction was d by 2. That was x bar was b by 2 and y bar was d by 2. Likewise, for rectangular section, we had considered a right angle triangle and we did the derivation for both along x and y direction, been placed in the first quadrant, and the base distance is again b and height of the triangle is height h. Now the center of this particular triangle with respect to the 90 degrees angle or with respect to the origin here, it is at a distance of x bar would be, that is this particular distance from the origin proceeding along the x direction or along the horizontal direction. X bar would be b by 3 and y bar would be h by 3. Then further one more session we had wherein we had considered a semicircle symmetric about a particular axis. So when we considered symmetric about a particular axis and y-axis been projected, so when it is symmetric about x-axis, then x bar would be 4r by 3 pi and y bar would be d by 2 or r or 0. Now these three formulas, d by 2 and r is one and the same. Whether we need to consider d by 2 or r or 0 is all dependent upon where exactly is the origin. If the origin is been placed at the center, then it would be y bar would be 0. If the same origin has to be shifted downward, like this, in this particular case, y bar would be d by 2 or r. So some textbook will prefer by considering this centroid, considering with respect to the midsection of the semicircle. In that particular case, y bar would be 0. If it has been considered at the far away location from the midsection, then it would be y bar would be d by 2 or r and x bar would be 4r by 3 pi. X bar would be 4r by 3 pi. Then the other formula would be from the curvature position, the formula would be r minus 4r by 3 pi, because the total distance is r. From total distance r, you need to subtract 4r by 3 pi, which starts from the chord of the semicircle, and the remaining left out distance would be r minus 4r by 3 pi. The same semicircle can have a projection in the upward direction also. If this had to be symmetric about y-axis and origin is been considered here, if it is symmetric about y-axis, that means y would be 4r by 3 pi and x would be either d by 2 or r or 0. Now 0 indicates if it has been located at the midsection, then it would be 0. If it has been located at the far away location from this particular center of the semicircle, then x bar would be d by 2 or r and y bar would be straight away as 4r by 3 pi. From the straight line it would be 4r by 3 pi. From the curved position, the centroid distance would be r minus 4r by 3 pi. So these were nothing but the formulas that we had derived in the previous session. So continuing further with the same formulas, we'll have the derivation for the quarter circle now. To have the derivation for the quarter circle, the quarter circle is non-symmetric section. It is neither symmetric about x and y. So it is like same like a triangular section. So we need to find out that we need to have the formulas for x bar and y bar. So consider a quarter circle. Consider a quarter circle being placed in x and y plane. Then in this particular quarter circle, consider a thin elemental strip, and this particular thin elemental strip, you consider it as a triangular strip now. This triangular strip, when you separate it up, it will be a triangular strip in this particular fashion. If this is a radius r and radius r, similarly this particular length will also be r. this particular inclination or the inclination of this particular elemental strip, it is placed at an angle of theta. So the curvature length would be r d theta. So this particular curvature length is r d theta, and radius as r and radius as r. Here, as it is forms a small elemental angle, elemental area, so inclination will be approximately 90 degrees, considering it as a right angle triangle. So area of this particular elemental strip will be half. As it is a triangular area, that is, I consider it as a area of a triangular portion, area of triangular portion. So this is half base into height, which is half r into r d theta, which is area of the elemental strip will be r square by 2 d theta. This is what is the area of the elemental strip. Now this area of the elemental strip, if it has been placed along the x direction, straight away coinciding it along the x direction, in that particular situation, this would be r d theta, inclination 90 degrees, this is r, and the approximately hypotenuse length would also be r here. Then, in that case, the centroid of this particular triangular strip would be 2/3 of r. But as it has been projected upward, means projected at an inclination of theta. So the centroid of that particular section would be 2/3 of r cos of theta, because x is, that is, if we consider this as an angle theta here and this as y and x, sine of theta would be y by x and cos of theta would be x. The sine of theta would be y by r and cos of theta would be x by r. So x is equal to r cos of theta. Now here we need to find out, that is, this particular distance is nothing but 2/3 of r that we need to consider here. Sine of theta is equal to opposite divided by hypotenuse, and this is adjacent divided by hypotenuse. So this centroid distance would be 2/3 of r cos of theta when it has been subtending an angle of theta with respect to the horizontal axis. So from the first principle, the formula is a into x bar is equal to integration x dA, wherein a is the area of the whole section. Now this particular whole section is nothing but the quarter circle section. If we recall the session related to the rectangle section, area of the rectangle section was considered, that is, whole rectangle section was considered b into d. For triangular section it was half of b into h, and then for semicircular section it would be pi r square by 2. Now here, since it is a quarter circular, so the area of the whole section would be pi r square by 4. The same formula we need to substitute the area of the quarter circle section as pi r square by 4, x bar as it is. Then integration x value, as mentioned earlier, x would be 2/3 of r cos of theta multiplied by dA. dA is nothing but an elemental area that we need to consider from this particular portion. Elemental area is r square by 2 d theta, r square by 2 d theta. Same position, r 2 and 2 gets cancels up, 2 and 2 gets cancels up, 2 and 2 gets cancels up, r and r square will get multiplied, so this will be r cube by 3 taken outside, integration cos of theta d theta pi r square by 4 x bar, left term kept as it is. So simplifying this, we need to integrate and then substitute the limits of integration. To substitute the limits of integration, we need to check out what will be the orientation or the degree of rotation of the angle now, because it has to be integrated with respect to theta. To check out that, we'll consider a quarter circle here. This particular quarter circle subtends an angle of theta. The same angle, when this particular triangular portion coincides with respect to x-axis, that means when it is being projected here, it is theta. When it is being projected along the horizontal, so theta here would be 0. Likewise, when the same triangular portion, when it is projected vertical, that is parallel to y-axis, theta would be pi by 2. So limits of integration would be 0 to pi by 2. So substitute the value of limits of integration as 0 to pi by 2. So solving this, this would be pi r square by 4, left side term as it is, x bar r cube by 3. Then integration of cos of theta would be sine of theta 0 to pi by 2. So simplifying here, r square on the left hand side, r cube on the right hand side get cancels. So as a resultant, pi by 4 x bar is equal to pi by 4 x bar is equal to r by 3. Then sine of theta, substitute the term sine of pi by 2 minus sine of 0. So simplified term will be pi x bar by 4 is equal to r by 3. Sine of pi by 2 is 1 and this would be 0. So x bar would be, cross multiply here, this would be 4r divided by 3 pi. So this is what is the centroid of the quarter circle along the x direction, which is nothing but x bar is equal to 4r by 3 pi. Likewise, y bar would also be 4r by 3 pi. Now here, if we redraw this particular quarter circle area and then check out, with reference to this origin, as the centroid distance has been taken with respect to the point O, so x will be considered with respect to the origin here, x-axis and y-axis. With respect to the straight line, the centroid distance is 4r by 3 pi along horizontal, and along vertical also it would be 4r by 3 pi. So these are nothing but the centroid distances for the quarter circular section along x and y direction. So if we consider from the straight line, it would be 4r by 3 pi. As the total distance is r, and if we happen to come across or the precision or the moving with respect to the curve portion, the centroid distance would be r minus 4r by 3 pi. So we cannot consider directly 4r by 3 pi for all the problems that we will come across. Sometimes whenever the quarter circular portion is been starting with respect to the curve portion, then in that particular condition, it has to be considered as r minus 4r by 3 pi. When it starts from the straight line, it has to be considered as 4r by 3 pi. For example, if I have a section been given, that is, if I have a problem which is a composite section, which is a rectangular and then the semicircle. Here, in this particular, if I consider the origin from this particular extreme left hand side, then in that case, I will be proceeding from the curve portion. That time, the formula that I need to consider here is r minus 4r by 3 pi. The same problem, if the origin is been mentioned to take the same section, that is a composite of quarter circle, a rectangular or square, and then the semicircular section. Instead of placing the origin at the far end, if the origin is to be considered with respect to the mid end, in that particular case, since you are proceeding from the straight line and quarter circle is on the left hand side, the formula has to be considered as 4r by 3 pi. And since you proceed towards the left hand side, you need to consider it as minus 4r by 3 pi. All distance measured upward will be positive, all distance measured downward will be negative. Likewise, all distance measured towards the right hand side is positive, all distance measured towards the left hand side is positive. All x bar distance measured for rectangle is positive, semicircle is positive, and here a quarter circle it will be negative if we consider origin being considered as shown in the diagram. If the origin is been considered as shown here, all x distance for quarter circle, semicircle and rectangular section, everything will be positive because you are going to measure all x distance towards the right hand side. So this is how we are supposed to derive the derivation for quarter circular section. Thank you. Have a nice day.